Hello, everyone, and welcome to our Tech Excellence meetup. So the vision behind our Tech Excellence community is to raise the bar of technical excellence across the world. And this is a short overview of some of our previous and current speakers. You can also join us on Meetup so that you get notifications about future events. Feel free to like our YouTube video and subscribe to us on YouTube. And you can also follow us on LinkedIn and Twitter to get future updates. So for today, I'm really excited that we are being joined by Pierre, who's a trainer and consultant at Craft Academy. And today he will be talking about test-driven development. So how do we write maintainable tests as executable specifications? So he will both discuss that topic and also show some code examples at the end. Feel free to write any questions that you have at any time during the chat, and then later during Q&A we will be going through your questions. So I'm really looking forward to this session. I think we will all learn a lot from Pierre. So handing over to you.
Okay, thanks, Valentina. Hi, everyone. I'm a little bit nervous because it's my first talk ever in English. So we will see how it goes. So today I decided to talk about how to write maintainable tests as executable specifications. I chose this topic because I think it's very important that our tests serve our purpose. And first, I want to talk about how to fail with TDD. There are a lot of possibilities of how to fail with TDD, but the main ones are by not challenging the requirements enough, by writing hard-to-read tests, and by writing brittle tests, by writing unmaintainable tests, and some people try to write all the tests at once. It's a big mistake. And there are a lot of more things, but we are just focusing on that today. So, what to aim for when doing TDD? Tests should tell the story of our software. They should be readable enough so we can understand what the software is doing and not how he's doing it. Tests should not break when refactoring code. They should act as safety nets to be able to refactor code very easily and without stress. And tests should act as a living documentation. Ideally, your test should be, your domain expert should be able to read your test or your test report and understand what is the feature you're developing. So, tests should tell the story of our software. To do that, the structure of our tests should be decoupled from the implementation of the test. The same way we don't want to test the implementation detail of our code, the structure of our code, we want to test the behavior. And the very structure of the test should not be coupled to the implementation of the test. We will see what this means after. So the structure of the test should be DEMP. DEMP stands for Descriptive and Meaningful Phrases. It's the test should be readable as plain English, almost plain English. And the implementation of the test should be dry. It's in the implementation of the test when we develop in production with the same patterns, with the same good practice, etc. But the structure of the test should not be dry. There should be all the information that we need to understand the test in the test. So there is some duplication between tests, but it's not. It's okay. Tests should not break when refactoring code. For that, we should focus our test on behavior and not on code structure. By focusing on use case, like Valentina says a lot, we should focus our tests, the entry point of our test, on the use case of our app, so our test become the first client of our app. It's like our test suite is like a console line application of our app. Not coupled to implementation details, because we don't want the test to be brittle and to fail when they do not have to fail, when we just change the structure of our code but not the behavior. And the test should depend on public contracts, because public contracts are the contracts that are the more stable. So we should focus on that and not, again, on the implementation details. Tests should act as a living documentation. So we know that the requirements are fully tested. This word is too difficult to say for me with my French accent. So let's say fully tested. It means that we should really think before writing tests. We should think about what is the feature we want to develop, what are we going to do, what are the issue we're going to encounter, maybe. So we should think about it before. As I said earlier, the test report and even the test code should be understandable by domain experts. In my team, actually, our test code is readable by our product owner. It is not, he is not a technical person, but it's readable because it's almost plain English. So tests are executable specifications, because we encode in our tests the specification of our software. And then when the tests are green, then it's the specification are executed. So tests are executable specifications. So let's take an example. Yes, it's another shopping cart example. I hate this example because we see it everywhere. But in fact, I'm actually working on this kind of example in the real world. So I thought it would be a good example. So the third step, for this example, we're going to work on a feature. It's add a product to a cart. So the first step is to think about some example that we want to implement in our feature. So the first one I can think of, it's the simplest. It's the one where the user adds a new product to an empty cart. So there is just a little description. Let's say there is no product in the cart. Then user adds one mustard at 250 euros to a cart. And the cart contains one mustard at 250, and the cart total is 250. Okay, very simple example. We will see later in code and how to structure the test for this kind of example. Let's take another example now, the one where the user adds a new product to a non-empty cart. So there is already one mustard in the cart, user adds one ketchup, and the cart contains no one mustard and one ketchup, and the total is good, if I did my math correctly. And the last example is the one where the user adds an already added product in their cart. So there is already one mustard in the cart and one ketchup, and user adds one ketchup to her cart. So the cart now contains two ketchup and one mustard. And again, the total is correctly computed. Now I want to speak about my own method or methodology to write better test structure. For that, I have only 5 steps. it's not. It's my method. It's not the best one. There are a lot of other methods to do it, but it's one I do now for a few years maybe, and it works great. So let's see it together. It's 5 steps. The first steps is to tell the story. So this step is not in code. It's in your brain. It's in your stickies, your notes. It's when you brainstorm with your team to find examples, relevant examples, just as I shown earlier with the examples. Then we should encode the story. This time we talk about code. The story should be encoded in our test to act as executable specification. As you know, a good test structure has 3 parts: arrange, act, and assert, or given, when, then. And the third step is to hard code the expected result in the assert phase to have a failing test, or to green test, and after that a failing test. Then we will see later what does it mean in the code. Don't worry. Then the goal of the step 4 is to connect the when step with the then step following the completeness rule. I will explain you what I mean by completeness rule. Don't worry. And the last step is to connect the then with the given step, also following this rule. By doing so, we have a good structure, correctly articulated of our test. So it's very abstract for now, I know. So I will show you in code what I mean by that. So Valentina, maybe we can switch to the code right now. Let me stop sharing up. Share screen up. This one. Okay. So don't mind the red wiggles. It's normal. So we start. We already done the first step. That was tell the story. It was the green sticky I showed earlier. So the second step now is to encode the story. So we're talking about a feature adding a product to the cart, and the example we're doing is adding mustard in the cart. It's in TypeScript, okay? And I will just show you what this is, because maybe you won't be able to understand if I don't tell you. SUT, or SUT, I don't know how to say it in English, stands for System Under Test. The name is not relevant. It could be context or anything you want. It's not relevant. The thing that is relevant is it acts as a context box, in TypeScript a closure for all your test implementation, because we want to separate test structure from implementation. So let's talk about the test structure. As you can say, I don't mind if the code exists or not. The code does not exist yet. I just want to write the story of my test in my language. Here it's TypeScript. So given existing product, okay, given cart, an empty cart, when adding product in cart, then cart should be with product mustard and total. It's as simple as that for the second step. We just want to encode the story in our test. Okay, now I will go to. Don't look at it. Don't be spoiled. Okay. Step 2 now. Sorry. Okay. Now the second step, I will open this twice so we can see in the same time the structure and the implementation. Okay. So the second step is to get rid of the red giggle because the function does not exist yet. So we just create a placeholder function. Okay. It's really a simple step. We just create the placeholder function without anything else. That's the second step, the following of the second step. The third step starts to be more interesting. Sorry, it's a bit messy. Okay, for the third step now, it's to return the expected result directly. Let me just start Wallaby. I don't know if you know it, but it gives me an instant feedback by running my test directly in the file, so I can see if it's green or if it's red. You know, if I put something different here, it's going to be red. Okay. So what did I do in this step? I just returned the expected result, okay, in the last step. So what do we have now? We have the structure of our test. Okay, it's done, but there is no production code yet. It's really a method to obtain a good test structure. So we have our test structure left here, and to the right we have the implementation of the test. For now, the given and the when step are not implemented. Only the then step is implemented by just hard coding the expected result. So the test is green. The next step is to connect the then step with the given step, with the when step, sorry. By doing so, by working backwards from the then to the given, we ensure that our test is correctly structured, because each step is correctly, how to say it, connected to the following step. You will see in a moment. So I'm just going to go to the next step. Okay. Now it starts to be interesting. What do I mean by connecting the step? Connecting the step is making them communicate in a way by something in common. Here, I added product ID in the when step, because it's the action of adding a product actually in the cart. And for now, we just save the product ID that we want to add in our test directly. Okay, it's not production code. It's just to create a test structure, a coherent test structure. And when I say connecting the step here, I use the variable set in the given step. By doing so, I connect the then with the given step. The given step acts on the then step. Sorry. So the next the next step is to do the same thing, but by connecting the when step with the given step. Let's do that. First, I want to tell you a little about what I call the completeness rule. The completeness rule is it's just to force you to not have unused variable in your in your test implementation, because these variables are not from sorry, how to say it. These variables have a meaning, okay, because they are there because it's in the story, so they have a meaning, and we should use them in our test. So I'm now going to connecting the other steps. No step. Donc, let's see a bad way to connect the steps that violates the completeness rule. Okay. So what did I do here? So, you know, there are some unused variable, like the added product ID is not used anymore in the cart, because what we did here is we use the existing product that we set in the given part directly in the variable, and we use directly this variable in our then step. By doing so, we have totally bypassed the when step, and our structure is not good anymore, because the steps should be connected. It's really a given when and then. So by doing so, we have bypassed the step, and the IDE tell us because there are some unused variable. So that's what I call the completeness rule. There should not be any unused variable. So let's see the correct example. Up. Okay, now to force us to use all the variable, we are now obligated to use a structure like product by ID to store the existing product. It's a bit like our future database, for example, but for now we keep it in memory just in our test to keep things simple. But by doing so, we correctly connected all the steps, because there is the empty cart at first, okay, containing products and total. Then we set the product in our product map, the existing product. And when adding a product, what we do here is we get the product from the map and then use it to push in the product cart the product with a quantity of 1. And then we assert about this object cart. So now all our steps are correctly connected, and we have started to write some production code, but directly in our test. But we are assured now that our steps are correctly connected, and we are not going to change too much this structure, and we are just now focusing on the implementation of the test and to extract the code that is actually in the test to the production into a production classes and something like that. That's exactly what I did after. So let's go forward. Maybe to this one. So the code you're about to see is not bulletproof code. It's not a very well-crafted code. It's just a code I wrote rapidly, quickly, just to show what I mean with this with this methodology. Sorry, I went too far. Up. Okay. So let's see our test now. Sorry, up. Okay. So what did I do in this commit? I think, yes, I extracted the when part into its own function and its own use case. It's very simple class, okay, that just takes a function to get the card and a function to get a product by ID. For now, it's very simple. Maybe I can put it side by side up. It's the same code. It's just in its own production class. So I only change the implementation here. The code here has not moved at all. Okay, that's the point. Now I think the next step I did is to extract some types. Maybe let me check. I'm sorry. Okay. Switch. Close that. Okay, now I've added some domain classes. Okay, it's just very simple data classes for now. It's very very simple. There are just a card, a product item, and a product. Okay, it's very simple. It's just to extract some knowledge out of the test to in order that this knowledge be in production code. Okay, so the tests now use the object here. We will see soon some patterns that we can use to write more maintainable tests. I will talk about, oops. Alors, so the same way we can make the notion of repository appear in our class instead of having a map. We can just extract it with the product repository if you know this pattern, and have an implementation, a fake implementation, a fake product repository for the product repository, a fake cart repository for the cart repository. And again, my point is that the only thing that changed are in the test. You know, yeah, the S code does not like don't like to switch between commit, but whatever. Here you can see the tests get more readable. The implementation of the test get more readable because we are using the new object we just created, product repository, cart repository, the add product in cart use case, etc. It gets more clean, and this still has not changed. Okay, now we will add other tests from the other examples, and after that, I will show you some patterns that you can use to create more maintainable tests. Okay, so this is the new test. Let's see what it is. Okay, so there is still the first test, okay? And now there is the second test. And we can see here that we are reusing the same steps. That's the whole point, because this here is what we call an internal DSL, a domain-specific language, specific for our test. That let us build our test like Lego, step by step, brick by brick, and to express our example very easily. So here the example is very simple. There are two existing products. We have one product in our cart, and here it should be 2.5. It's not relevant for here. And when we had the product, the total should be 4.5, 450. Sorry. Okay, it's just another example. The second one I shown earlier. Okay, now we have a problem, a little problem. There is some duplication of internal structure knowledge. What I mean by that is, for example, cart here, let's put it. The cart is built in a certain way, and we're doing the creation. In multiple parts. The problem with this is when the structure of the cart will change, or the way we have to build it, we will have to change everywhere the way we build the cart. So to overcome this, we can just use a very simple pattern, the builder pattern. So let's see how it looks. Up. Switch. Okay. So now we have two builders. Up. Don't mind the red part. It's because I need to relaunch Wallaby. I will stop it. So we have a card builder. Let's focus on this file for now. It's the builder pattern, but a very, very simple implementation. Okay. The builder pattern lets us create one and only one place where we build something. So if the building of this thing has to change, we only have to change it once and not everywhere in our test. It's another benefit of the builder pattern is to allow to easily have default parameters. As you can see here, I won't dive into the details here because it's a TypeScript implementation. It's not relevant for us, but one thing that is relevant is that the builder pattern lets us be more fluent when writing our code too. So, for example, I replaced the code here by using the builder. Okay, it's the only time I change the structure part of my tests. It's to make it more readable and more fluent. Here, it's even more readable than before because it used the builder pattern, and it's obvious that here we are building an empty cart, for example. And here we're building a product with ID mustard and priced $250. Okay, so I use it everywhere to assert the resulting card too. This builder pattern let us focus on only one place, the construction, the building of our object. It will be very important later, you will see, and it works great in combination with another pattern I will talk soon, maybe not just now, but or maybe I don't remember. Yes, it's the memento-like pattern. Let's see that. I'm just closing this. Okay, now in my domain classes, I have this method, okay, to create a cart from state, and the state is what I called earlier a public contract. Okay, this state contains only scalar type. Okay, no domain type, no value object, only a string, only numbers, boolean, something like that, and this acts as a public contract of the state representation of our cards, independently of the implementation detail of the card. Okay, again, don't mind the red waves. It's because the Scott does not like to switch between commits like that. So I have it for cart, I have it for product item, for product, etc. And by doing so, in our card builder, we are no longer using new cards. When you're using new, it's very how to say it. It's a very strong coupling, because it means you know how to construct an object. By using a static builder, it hides the way we build it. We build it, sorry, and we only use the public contract of what a cart is in our domain. So it's, as you can see in the pop-in, it's just a list of products and a total. Very simple. It's the same for the product builder. The product builder, it's the same thing. We just construct it from state, and that's it. I don't think anything has changed in the test for this, because it's transparent. Okay. What is very interesting with these two patterns, it's that it lets us refactor our code towards a more richer domain model very easily, without changing the test. I will show you that. So let's move forward to this commit. Okay, so the test hasn't changed. Okay, it's the same test. I think there are 3 tests now, but yeah, it's all the 3 green example I shown earlier. But the test hasn't changed. What has changed are the domain object. There are no more, how to say it? There are more logic in the domain object now than before. As you can see in the add product to cart use case, all the logic is delegated to the cart object. So we'll see it. The cart object has now a add product method that delegates the creation of the adding of a new product item to his product item list. Again, it's a rich product item list is a value object. Okay, and we have delegated all the logic about increasing quantity, about adding the product if it is not already in the cart, or just increase the quantity if the product already is in the cart. We moved all of this in domain classes, and without changing anything in our test, because the public contract, the state, remain the same. It's the same. It's the same public contract. So our test here has not changed at all, and that's the power of using the builder pattern with the memento-like pattern, because we are not coupled to implementation detail, and we can easily refactor towards a richer domain model, towards maybe fewer or more classes. We are free to do whatever we want. That's the point. I think I'm good for the code, for what I wanted to show you about the code. I'll switch back to the presentation now. Alors, okay, so now a quick sum up about the pattern we use. So the builder pattern to centralize the creation of an object and to be able to write more fluent code and to be able to have default parameters. It's very handy because when you write tests, you only want to have the data needed to understand the test, and you don't want to pollute your test with all the parameters that your object needs, because it will make the test less readable. We only want the data needed to understand the test. So the builder pattern let us hide these not relevant data in default parameters. And the memento-like pattern to expose some public contract about the state of our object to depend on, and not to be coupled to implementation detail and to structural details of our object. That lets us refactor our code without breaking the test. And now, that's just what I just said. What about the front end now? I expected to talk about the front end in this talk, but it would have been too dense, too long. So just a few words. What do we need in the front end to work with this clean architecture? We need view models to encapsulate state change logic, and we need to be able to notify state changes. For example, we might have a product list view model that triggers the fetching of the product and display a loading while the products are loading, and then eventually display the product list. We need to have reactive ability in our apps. We need to be able to react to events, like okay, the product list has been fetched, or the product cart, a product has been added in cart, something like that. We need to be able to react in real time to events. For example, the card view model, we need to handle the fact that when we add a product in the cart, we only have its ID, and we need to be able to display the product from the list fetched above this in real time. So we need to implement a custom pub sub if we want to do this. And we need to implement a custom local caching solution to avoid having to refetch everything twice. And we need to have one place when every entity has its state, and one place to update it when fetching or updating data. It's a lot of work, and we don't have to reinvent the wheel. I'm going to talk about Redux. In the front end, Redux gives us all of that and more for free, because it's in the very structure of Redux to be reactive and to be event-driven. It's a very lightweight pub sub with middlewares and something like that. It's very lightweight. And we should use it as a first-class citizen in your app. What I mean by that, it's not worth it to put Redux outside the hexagon. It's just not worth it. Redux is not a framework, okay? It's just a tool. So it does not break the clean architecture, no framework policy. Trust me, if you use Redux outside the hexagon, you will do a lot more work for nothing, just to keep some purity, but it's just a lib. It's like you were saying, okay, I'm not using I'm not using a Lambda, or I'm not using Rx JS directly in my core, and I want to re-implement all the observability, all the operator of reactive of Rx. It's just does not make sense. Just use Redux in your hexagon, and everything will be simpler. The use case are the thunk when we talk about Redux, or epics if you use Redux observable. And the view model will be some kind of selectors and method for dispatching use case. And by doing so, we can test almost all our application outside the context of the front-end library, like React or Angular or Vue or something else. Everything is pure TypeScript. So we don't have to struggle with a React testing library or something like that. We can, if we want, do some integration testing to be sure that when I click on that button, that method of the view model is correctly called, etc. We can do that, yes, but most of the time for simple app, for simple forms, it's just not worth it. That's my opinion. It's not everyone share it, but that's my opinion. I think we are done on this. You can find me on LinkedIn, and I have my newsletter. It's in French, but I know that some English-speaking people do read it by translating it. But it's in French. But it's on hold for now. I think I'm going to write again, maybe in next year. So if you have any question.
Okay, great. So we can then go on to the Q&A. So first of all, I really liked this presentation, and even in the code, you actually showed us quite a lot. It wasn't just like a simple kata example, but you went further, and there are also, similarities to Dave Farley's approach, which we might get to later during the discussion based on questions. And even for French, I just want to say I watched your French YouTube videos as well, so that's another thing that people can look at.
It's on hold.
Yeah, but they're still good. So yeah, okay. In any case, we can now go on to the questions. So how do you define contracts in non-statically typed languages such as Python or Ruby, i.e. when you don't have interfaces provided by your language?
These in this case, the interface is the signature of the function. You don't have other choice because there is no interface. So the signature of the function is the interface. So there is not much thing you can do.
Yeah, exactly, because the word interface has also a more abstract meaning, like as in signature or contract of something. It's not necessarily like the interface keyword. The next interesting comment about the readability of the test. So not only understandable by domain experts and PO, which was the part that you mentioned, but written with them. Have you ever
that's the theory, and that's the whole point of Cucumber, for example, of Gherkin. But in practice, I never saw it done, because in order to be able to write good specification, you need to understand what is testable code, what are the different steps, and you should be developer to write them. But it's not right. How to say it? It should be a team work. Okay, these specifications should be written by the dev, by the product owner, by the domain expert all together. In fact, when you have those kind of example I showed earlier on a green sticky note or something like that, it's already a specification. So then you only have to encode it in your test in code, but it's the specification. So this has to be written by the team, not by one developer alone or one product owner alone, because it's about communication.
Yes, and even understanding requirements. That way people can be more certain did they understand the requirements. But of course, even to these meetings, when it's the whole team, even the product owner in this case could be part of, I guess, when we're
Yeah.
writing the
Sure.
test. Okay, next question. How to use test-driven development using Selenium, because the UI is changing when a new design is implemented. Oh, and also I have one more question from my side. How do you handle the whole HTML aspect also in front end? I mean, do your tests just go to the view models, and what happens to the HTML that's rendered, and then when the design changes there as well?
So I'm going to answer the first question first. You can't do TDD with Selenium or even with Cypress by definition, because the feedback loop will be too slow, and it won't let you discover step by step your features. It won't let you move very in very little steps. It's too big, and as you said, the UI is changing a lot. So you you don't want to test the UI. You want to test the interaction, but not the UI. So there are many possibilities that you can use. Some people like to write tests as if they were blind. It's they're targeting ARIA labels, something like that, because these things are not changing a lot, because they are the things that are used for screen readers, to inform blind people, for example, of what you can do on the screen. And a test is blind, so it's actually, it makes sense to use the same tools to write this kind of test. But personally, I don't write this kind of test, because I have maybe one big end-to-end test to test a workflow with Cypress or with Selenium, if you want, to test, for example, the whole checkout workflow, for example. But I won't use it on a daily basis. I don't mind about the HTML. I can write tests for testing the integration. Like I said earlier, I want to be sure that when I click on that button, this action is triggered, or when I click on this thing, this page is shown, or something like that. But for the HTML, we can just see with the eyes if the things are good, because it changes too often to be able to write a robust test.
Mm-hmm.
And that's
Yeah.
the whole point of creating a humble object with view model and something like that, because you can extract the logic from the UI, and you can test it without all the UI layer.
Yeah, I think this is a good point. So in summary, HTML testing, I mean, we can cover with some few end-to-end, tests with Cypress, but really minimizing. Now, the next question is, our entire tests are based on UI, only few on API. I've seen this happen in a lot of companies who are doing a lot of, for example, Cypress testing, and very few on API or unit tests. Can you maybe say your commentary, or
Yeah,
what are the problems with this?
it's very common in teams that do not do TDD, because when they have not a code base that is very testable. They have not an architecture that is very testable. So the best return on investment is to do end-to-end testing, very black box testing. But takes time, and it's very cumbersome to test every single scenarios with that. So yeah, it's your only solution when you don't have tests. But I've seen some teams that have effectively some Cypress tests, but then use it to be able to refactor their architecture in order to have a better tested architecture and testable architecture, and then switching from a lot of Cypress tests to just few Cypress tests and a lot of unit tests. But yeah, if your architecture is not testable, you have no choice but to create a Cypress test that in a black box manner.
Yes, and another also point is there's a lot of companies which sell, for example, no code or low code type of solutions for QA, and then it's quite attractive for managers to buy these kind of
Yeah,
solutions, but then they experience later all the brittleness. And the other point in this whole thing is the feedback loop is very slow. So to get
exactly.
feedback from this, you have to wait for the entire front end to be implemented and the back end and integrated. So it's quite the opposite of TDD. Now the next question we have is, it's like your SUT is not actually, so system under test is not actually system under test, but a stateful test structure that tests the
Yeah,
real system under test. So maybe you could elaborate.
exactly. You're right. It's just because I use this term. I'm used to use this term, so it's not exactly the real set like you said. Maybe a better name would be context or something like that. But it's just up to the team to find a correct name for it. But you're right. It's not the real system under test.
Yes, and maybe, I mean, since in our previous discussions we also talked about Dave Farley and I mean the whole abstraction which is being done here. I mean the protocol and drivers.
Yeah.
Maybe you could give some short overview of that as well, because actually several comments we received and discussion was about this particular topic.
Yeah, it could be just named DSL, for example, instead of set.
Yes, it's essentially the DSL
Mm.
for running the test. Okay, another follow-up. To be honest, my first feeling of this is that it's a bit of overthinking and not really necessary. I don't see the point of all that test structure. Maybe if you could explain why you have that, why not directly, targeting the SUT or something like that.
We could have written directly into the test the implementation detail of the test, but we would have mixed the structure of the test and the implementation, and we would have mixed. It would have hurt the readability of the test. And if we wanted to keep the test readable, we would have extracted some part of our test into helper methods, and finally eventually ended up with some kind of the set object I showed. So I just start with it, and so the tests are easily readable like that, and you don't have to first read all the implementation to understand what are the specifications. That's the main point. You want to be able to just understand the specifications first, and when you need it, and only when you need it, go further and understand the implementation to edit it or to just whatever you want. But first and foremost, you write tests to be readable by other, to be understandable of what you are testing, what is the features.
Yeah, so basically these tests are human readable, unlike the API inside our system. The API could be fine from a developer standpoint, but would maybe not be readable, and then that's why people have to then make test helpers so for example, test helpers for setup, and also test helpers for assertions, which is something that I had to do in the previous example that I showed, which was, for example, a test helper for setting up the repository with certain things. But then the issue there was that I'm mentioning the word repository, and the word repository is not understandable to someone in business side. So I guess this is the benefit of this additional layer
Exactly.
of abstraction. And maybe even later after this recording, even sharing some maybe YouTube links regarding Dave Farley would be useful, because regarding this approach. The next one is, so on the right, he wrote some code to interface with the real app and to make it easier for him to create more descriptive tests for the left pane. Is that...
Let me rephrase it in my head. Interface. Yeah, the left pane was about the specification, the structure, so about understanding what we are testing, and the right part is about the how we are testing it. So I separate the two, like I said earlier, to be able to just understand the test by reading it, and not be forced to dive into the detail of test implementation. So yes, I create this interface to make the test more descriptive. That's the whole point.
Mm-hmm. Yeah, good. So we could say the test is reflecting the expected behavior without going into the structure of how it's going to be implemented. Okay, so is it true that here given stands for range, when act, and then stands for assert?
Yeah, exactly.
Okay,
You name it like you want. You can.
great. Will this repository be available somewhere on GitHub or anywhere so that people can...
Yeah, I will share the link. I don't know if it's
Okay, you can then paste it
later. Yeah.
after the meetup. Great to hear that. Okay, the additional layer is for giving the structure necessary to tell the story for both a technical and non-technical person, if I got it correctly. So maybe you could comment.
Exactly. Yeah, that's exactly that.
Okay. Now, what's your perspective regarding builders and fluent assertion, which are also readable by anyone? How would you compare and maybe contrast the...
I don't usually use fluent assertion, because all my assets are just expect this to equal this. So it is readable because I have something like expect cart to be equal to expected cart. So it's understandable by everyone, and to see what the cards are about, you can refer to the builder. So it's readable enough. In my experience, it's readable enough by developers and by product owners like that. But I'm not close to to use. I'm not against using fluent assertion, but I just didn't have the need for now.
Mm-hmm. Yeah, even from my side, I ended up moving mainly to asserting like the whole expected result, because that actually gave me more confidence.
Yeah.
Versus just asserting specific fields, like are they correct,
Exactly.
instead the whole object. Okay, another related comment is you could use the mother pattern instead of, for example, the builder pattern less code. So I guess that's yet another...
Yeah, I'm not very fond of the mother pattern, because I think in contrary, it's become a very bloated code after that, and it's less reusable, in my opinion.
Mm-hmm. Okay. Another comment, it reminds me of BDD style tests, but done manually without any library.
In fact, what everyone calls BDD style test today is just TDD test done right. TDD test should be written in the same way by focusing on the behavior. And I think you're referring you're thinking about Gherkin test maybe, and you could totally do TDD with Gherkin in the same way. It's what we call an external DSL because it's not in the same language than your code. And for me, I think it's another level of indirection. It's a bit too much for me. I prefer to write it directly in the language I write the software. It's just a team preference.
Mm-hmm. Yeah, and good point how you mentioned that TDD is just BDD is just like TDD done right. And even historically, when Dan North came up with BDD, he was doing TDD trainings, but people had issues understanding what's a test. So then he started using the word behavior, and he's like, I just find the word behavior is more useful than test. So I guess that's a short history.
Yeah,
And I also like. Mm-hmm.
and when we say behavior, we don't say behavior between objects. We don't say we need to test that this object behaves in this way with this object. Okay, I should accept that this object has called this one with this parameter. No, it's not that. It's behavior. It's user-centric behavior. It's behavior in the in the user point of view, not behavior of the structure of the code.
Yes, the externally visible
Exactly.
behavior to the caller or client of this a system. And the other also good point that you mentioned was the two types of DSLs, external and internal. Another benefit which I find regarding is internal DSLs is that it's less brittle compared to Gherkin.
Yeah.
So that's another, I guess, maintainability. Okay, the next topic we have is this comment. I like to make a distinction between test builders, lots of defaults, and production builders, only defaults if needed for the production code. Most of the time, test builders wrap the production builders. So maybe you could say something a bit about that.
It's true. Yeah, when I use builders for production, I do this too. I have my test builders that use production builders with and the default are not the same for both. So yeah, I agree.
Okay, we had another comment about builders. Builders do not respect CQS, so personally, I see a builder in production as a code smell.
In what regard it does not respect CQS?
Or maybe, I mean, Francois, could maybe write even follow-up comment if there's anything additional. We can move on to the next comment. I've always wondered if decoupling the domain versus infrastructure, basically the front end, is useful or doable as we can do with the backend. Now, my interpretation of this question is that in backend it's easier. Like in backend, it's quite easy to decouple the domain and infrastructure, and I mean that's where clean architecture came from. Like they were always like backend centric, but in front end, to what extent can you do it, or is it useful or not useful?
Is it useful because you don't the clean architecture on the front end lets you start by the front end without the back end. and you can show your users, you can show your stakeholders what you've done without having a backend, because by separating domain versus infrastructure, you can use fake data, you can use you can even use maybe local storage for testing purposes, something like that. But yes, it's very different, because on the backend you have all the integrity check. You have some patterns to ensure integrity, like aggregates or something like that. You have transactionality too. In the front end, there is nothing like that, except for client-side application or client-side features, like a shopping cart, for example. Shopping cart, it's only on client, so you have you have some integrity things to check, sorry, to do. But 90% of the logic in the front end is about fetching data and displaying it, and refreshing only what's needed in your app. So it's not the same. It's not exactly the same in the backend and in the front end, and that's why I think it's not a good idea, and it's not even possible for me to have the same clean architecture for the backend and the front end, because those are two different applications. They have different needs, and they do look similar at first, but they don't have the same purpose. So the clean architecture on the front end, yeah, you will have a lot of gateways instead of repository, for example. So the logic will be mostly on not the logic, sorry, but the use case are going to be a lot of just pass through to the repository, because the repositories or gateways on the front end act as a facade to the real use case in the back end. So your application layer in the in front end will be very lightweight in comparison to the back end side.
Yeah, and maybe we could also say that these use case tests on the front end, they're essentially testing the transformation. So if
Exactly.
you have certain structures, DTOs in your, for the repositories or gateways, okay, how do they translate to the view model? It's pretty much that most of the time, and maybe sometimes calculation.
All the reactive stuff. You want to test that when you receive something, this thing happens to all the things that are only relevant on the front end for the user experience. You need to test it. It's the front end business logic. So this needs to be tested.
Okay. The next question, what's your opinion on parameterized tests and data fuzzers? Do you use them?
So I use parameterized test, and I don't use anymore that data fuzzers, because I'm not using data fuzzers anymore, because I do want to be as explicit as possible about the data, and I was sometime stabbed in the back by some random things happening in fuzzers that I did not see obviously. So I do not use them, but yes, parameterized test, yes, I do use them when I need to test multiple scenarios of validation. For example, I have just a kind of data table like in Gherkin with multiple scenarios for validation, like null, undefined, invalid value, something like that.
Mm-hmm. Yeah, and another also point I'd like to add, I mean, I also use parameterized tests, but regarding data fuzzers, I don't use them because they cause non-determinism, because then our tests are random. So for unit tests, I actually want full control of determinism.
You can actually in TypeScript with I don't remember the name of this library, but you can set the seed and when testing. So there is always the same randomness. But yeah, it's
It's
I think
still
it's not worth it.
Yeah. Okay.
It could be useful for generating some texture though, maybe, but just generating once and then fixing them in the code.
Great. Okay, I guess there was another follow-up topic about Java and builders and how is that associated with this. So I guess that's a whole other topic, which maybe might be continued in comments later. And also we got this message, so thanks for your excellent presentation.
Thanks to you.
Okay, that's good.
And great first name.
Yeah. And where Peter is also, I mean, he also had a meetup before for the Bucharest software craftsman community with Victor, where he also showed like human readable DSL like tests, and he will also be speaking at an upcoming session. So whoever likes it, and I think it's going to be similar as the approach that you have as well. Another one, if the use case is quite complex and you need to unit test on smaller components as well as on complexity, do you have any preferred patterns? I think this is definitely a really popular question.
I think when you're saying smaller components, you're not talking about React component or something like that. You're just going.
I think that maybe this is in a more generic sense, maybe not front end, because I've seen this question appear a lot for back end.
When the use case is quite complex, you have many options. The first one is you have to ask yourself, is this use case doing only what he needs to do, or am I trying to do too many things in one use case? That's one thing. If you think this use case is doing exactly what he has to do, and then but this use case is complex, then you can do what we call shifting gears down. It means that you can go a level deeper in your code, and unit test this level. So your client is not anymore the use case, but is the component you're working with. You're testing it in isolation. By doing so, you have to keep in mind that those tests are coupled to your implementation, but these tests can greatly help you to build your component and to discover the complexity and to move by baby steps and something like that. And once everything works together, you have two options. Whether you keep your those tests, but you should keep in mind that those tests are more brittle, because if you change the implementation detail, those tests will break. Or you can just create scenarios for the use case that use all the logic you use in your smaller components, but removing the test on the deepest level. So it will only be tests that you use to be guided, but now you can safely remove them because they are covered by higher level tests. To help you write a more maintainable test and code, and to discover by doing small steps. By coding with a quick feedback. So if it happens that you don't have a quick feedback when doing on the use case part, just move deeper to have a greater feedback, but don't hesitate to remove those tests after.
I also have a follow-up question regarding that one. Let's say the application, we're doing some bank account scoring. So I don't know, bank has customers and maybe wants to give scores based on how much money customer has in the company or how many transaction customer has. And let's say that calculation has multiple factors that need to be calculated, and then each factor has like a whole heap of if-else statements, logic. And maybe there's 50 factors which might need to be multiplied. I asked this because I also had a similar case in a previous meetup. I'm interested, how would you handle that?
To avoid how to say
combinatorial explosion.
Thank you. I didn't have the case in my project, but I think I might be doing some low-level tests and one or two higher-level tests, maybe in the use case part, and a lower-level test for the unit, to test the unit between them, and maybe only the contracts between how the units are linked together, but not every scenarios, because it's impossible.
For me, that was the only case where I actually ended up keeping the lower level tests, because the bank later adds, aside from the 50 factors, it adds the 51th.
I think I would do the same, to avoid the combination.
So I see that as the main exception which I use compared to like pure use case tests. Okay, maybe some internal abstractions will split into multiple use cases and do orchestration through a facade. The idea where unit tests should focus on behavior and not implementation details. Oh, sorry, this was linked to the previous question.
Okay.
I think, did we answer? I think we answered this.
We should not orchestrate multiple use cases. In fact, if you're doing this, your facade will be the application, the new use case, the new application service, because it will be the new client of your business logic, and your use cases will be some maybe domain service, because you don't want to have a use case calling other use cases, because it will be a mess after to know what breaks if I do that, if I do this, something like that. So no, I think you should focus on what we said earlier.
Great. Okay, we had another thank you, and well, there's more thank yous, but now we're going on to the next. Okay, the cases presented here are the happy path, but for my cases, I sometimes find myself lost in testing the expected exceptions to be thrown. Do you have experience difference in applying your approach?
Indeed, you have to test the not happy path. So to do so, it depends on the team. I like to. It depends on. Actually, it depends. You need to test that your use case is in error. So whether by testing that the use case thrown some expected error, or by testing that the use case return some object representing the error. It depends on how you want to handle the errors, but it would be the same. In the test structure, you would have something like maybe if maybe there is a rule that says, okay, you can't add 3 mustards in your cart, for example. Then in your test, you would have something like, given my cart with 3 mustards, when adding mustard, then an error should be thrown with the error like new count maximum quantity reach or something like that. It's still readable by using exception names. So that's how I do it.
Also, continuation of this one regarding the number 5, it was referring to 5 steps, like the 5 steps that you showed at the start. Do you use them for unhappy path as well? Like, are they...
In fact, the steps, I showed the steps in great details, but when you're used to it, you can go way faster than what I've shown. It's just to help you, and you usually start with the happy path. So the happy path gives you some DSL steps that you can reuse very easily in the wrong path. So you you usually have only one step to add one then step, saying then it should have thrown an error or something like that. So you don't have to repeat all the 5 steps for every test, because it's by reusing the steps you are assured that you are connecting them correctly, and so you don't have to reapply the 5 steps for every single test.
And another also question regarding unhappy paths for use cases. Do you throw exceptions from use cases, or do you return like a failure result object?
Yeah. It depends. It really depends. I don't have. It depends on the team. It depends on many things. Sometimes I just return an object, an error object. On the back end, I don't throw, because I prefer returning an object with a result and with events that are dispatched. So I don't want to throw error here. But in the front end, I generally throw errors, but it depends. I don't think.
Great. We also had another positive feedback. So your first English
Thank you.
meetup is great, and I hope that you will have more meetups as well on English, simply because we'll reach or on a more global level. Okay, should you mock the behavior of backend when testing the front end, and changing the mocking front end when the backend changes? Probably changing the mock on the front end when the backend changes.
The ideal way of doing things is the backend should be driven by the front end needs. The front end needs to expose contracts that the front end need to display some things, or the query they have to fetch or something like that. So the front end can mock or use fake or something like that that respects these contracts, and then the backend have just to respect these contracts too. If you want to have more reliability, you can use contract testing with some tools. Like you have a few options. You can the simple one, or simple or not, it depends on your team, but the front end team can write tests, contract tests, just test that test the query, and expect that the query has the corresponding has the correct shapes, and had these tests in the pipeline of the backend. So when the backend when the pipeline of the backend is run, the test will fail if the backend change something in destructive way. So that's a way of doing this. And then you can use some tools like pact.io, where the front end describe the contract they need. Then this contract is uploaded to a server, and then in the pipeline of the web of the backend, they download this contract and run some tests against it to know if anything is broken or not. It's very useful when you have a lot of different front end, and you can't know if any of them still use this tail or not, or something like that.
Okay. We also got a comment. What I like about this approach of having a DSL is that you keep separated the specification layer and the automation layer, as Gojko Adric, mentioned in specification by example. So I think that this is a nice summary about the approach. And also, so you ensure that you really thought about the specification that can survive implementation changes, because here we're actually free even to later change the API of the solution without breaking the test, versus the test that would have been maybe directly coupled to the API
that's
of
the
the
whole
user.
point. Yeah.
Okay. We also had yet another thank you. And okay, can we have a link to the presentation itself if possible? So is it maybe possible
Sure,
for
yeah.
you to upload the presentation maybe on your website or anywhere else, and then
On
link?
the GitHub, maybe I will
Yeah,
put it on the
excellent.
GitHub
GitHub,
repository.
put everything on. Okay. Okay, and another one. I'd like to see the Redux code TDD within a hexagon on a code repo that you're willing to be shared. So
I'm doing it. It's on my schedule. Sorry, it was not finished for today. I haven't managed to finish it for today, but I'm doing it. So
that's fine. So I guess whoever is interested, after you provide the link to the GitHub repo, then whoever is interested can follow you on GitHub and start your GitHub repo, and then we'll get updates after you do those commits as well. Okay, how do you test error handling when fetching data from the front end?
as I said earlier, you define contracts. You define what can go wrong with fetching. You dissociate operational error and application error. Operational error are errors that if I don't mix up the term, there are two kinds of errors: expected errors and unexpected ones. So you should test for both. And for the expected errors, you should have your own your own error in the front end, so you can sorry. So you can have specific message error or specific behavior based on the error on error. And for the unexpected errors, just catch them and use them to display some toast or something like that you can test separately.
Great. Okay. So, okay, another thank you, and
Thanks, François.
another thank you. Okay, great. This was, I think, an excellent meetup session because we covered both, I guess, the overall topics of test maintainability, but we also touched both on, back end and front end, and I think that this was really great to see this. So as follow up, I guess you'll be able to share any links on our meetup page, and we're looking forward to following you on GitHub. To see the updates on the repository. Really excellent example. So yeah, thanks a lot for the session today.
Thanks.
Okay. So thank you very much, everyone. Just to finish off, feel free to join our group on Meetup if you haven't already joined, so you'll get notifications for any future events. Also, please like this video and subscribe to our channel if you find this kind of content interesting, and you can also follow us on LinkedIn and Twitter for future presentations. And here's yet another thank you, and another thank you. Okay, people liked your cat.
He's sleeping actually, yeah.
Well. Okay,
right
so
now.
thanks a lot, everyone.
Thanks a lot.
And see you next time.
Bye.